Welcome to the Game Dev Pantry, a series where we retro-engineer interesting mechanics in Unreal Engine. In the previous episode that focused on Hollow Knight, we added animations for the basic movements, as well as implement the functionality of attacking. Today, we're going to tackle most of the power-ups tied to movement that are found throughout the game. This means the dash, the wall jumps, and the double jump. But before we head into that, we'd like to apply some corrections to the previous version. First, in the attack scan function, between the getAllOverlappingActors and the forEach macro, we'll create a local variable for the overlapping actors to feed into the forEach. The reason for that is because otherwise, the code will fire getAllOverlappingActors before each run of the loop, which is redundant and heavy. The second thing we need to fix is in the setAnim function. Before we turn the character around using the look function, we need to set a condition that confirms that we're not currently attacking. We don't want the knight to turn around during his attack animation. The next thing is in the input section. Let's make sure that the player can't input horizontal movement during the small moment he suffers a knockback. Simply use a branch with the bool knockback. The final thing is a fix in the instant acceleration module of the resolve movement function. We'll remove the select that checks if the velocity is equal to 0. Our output will just be the added velocity or the initial input. We do this to prevent the wall slide from glitching. And that's it. Let's get back to the main subject. The movement power-ups in Hollow Knight are all quite satisfying to use. And part of the reason for that is that they complement basic movement and each other very well. Each power-up has multiple uses, as well as specializing in a specific area. Given how important each power-up is to the progression and the expression of movement in the game, they not only had to be distinctive, but the game also had to teach the player in which ways these moves are. Like any good Metroidvania, Hollow Knight does that through a good mix of declarative, procedural, and conditional knowledge. These are categories of knowledge that any learning process strives to teach. Declarative, for example, is the knowledge of facts. When you acquire a power-up in Hollow Knight, a small description pops up explaining how the power works. This is an example of declarative knowledge. Once that has been taught, a good level design would force the player to use that newly acquired power. This teaches the player the real-life inputs, often the press of a button, to use that power with. That would be the procedural knowledge. In the case of the dash, you are presented with a gap that you can't jump over, and therefore have to use that new power-up. A big gap is an example of a situation where the power-up is required. A condition of use, if you will. In the case of Metroidvanias, the player might remember other places where the dash was required. This is a case of applying conditional knowledge, and Hollow Knight is filled with those. It even encourages the player to think of new situations where the power-up might be used. Let's keep the dash as an example. The game very quickly teaches the player that it is used for crossing horizontal distances. But while it never explicitly mentions it, cancelling vertical momentum is another of its properties. Most players will realize it instinctively. This is an example of the game skipping declarative knowledge and going straight to procedural. We'll start with this power-up for the retro-engineering phase, since it's the simplest to do given that it has a fixed travel distance. We'll start with our usual trio of functions: start dash, dashing, and stop dash, as well as variables for timer, speed, acceleration, and direction. We'll also make a dash counter variable, as well as adding a new movement mode in the enum, which we'll call dashing. Now that we have a new movement mode, we need to check the places that this movement mode will be used. This mostly means our big resolve movement function. We can see that adding a new movement mode in the select has all of its default values to 0. We're going to add select nodes for the horizontal and upward movement. Before we only needed to modulate downward movements. For vertical movement, this is what we want. The dash stops all of it. For horizontal movement, we'll just plug the dash speed variable we created. In the movement change function, we don't want our movement to change when we're dashing, except to switch to falling. Therefore, we'll make a condition on rising, jumping, and grounded to not activate if the knight is currently dashing. Let's head back to the start dash function. This function will check that the dash counter is below 1. You can't dash more than once before it refreshes. Then, the dash counter will be set to 1 and the dash direction will be based on the current look direction. After that, we just need to change our movement mode to dashing and clear the timer for the ungrounded function. The reason for that is that the ungrounded function sets our movement mode to falling, which would cancel the dash immediately. Once that's done, we can move on to the dashing. The dashing will, of course, check if we're currently dashing, in which case it will add the velocity and the timer to the appropriate values. If the timer is equal or bigger than the max duration, then we trigger stop dashing. Stop dashing simply sets our movement mode to falling. After that, we need to make sure that when we get grounded, the dash refreshes. Actually, while we're at it, let's collapse what happens when the knight touches the ground into the grounded function. To refresh the dash, since we'll need to refresh the double jump as well, we'll create a refresh moves function that gets fired when you touch the ground. For now, this function only needs to set the dash counter back to 0. The final thing we need to do is add the dash animation to our set animation function. Good for us, we already have a select node already updated from our enum. If we press play to check how it's handling, we notice that we can change the direction during the dash animation. Therefore, we need to add dashing to the list of things that stops the sprite from switching direction. We also need to prevent horizontal movement input during the dash. The next thing we'll work on is the double jump. This power-up is a staple of the Metroidvania genre, and is very self-explanatory. It's quite easy for the player to understand the possibility of this move. During my first playthrough of Hollow Knight, I thought the double jump worked differently from the regular jump, because it felt so different from it. As it turns out, it is almost the same in terms of metric, aside from two small but key differences. The first one is the animation. The double jump has a much more detailed animation than most of Hollow Knight. It is lengthy with great movements, and this makes the double jump feel heavier as opposed to the usually twitchy movements of the knight. To contribute to this feel, the double jump also doesn't cancel momentum at the beginning. This means that if you double jump while falling into spikes, you still might die because it couldn't stop your descent in time. This also makes it a bit less maneuverable and precise than other movement options. These design choices are very clever, because it means that during boss fights, for example, this power-up isn't a clear-cut choice to dodge attacks. It is already quite good given that it has the expressiveness and maneuverability of the regular jump, without the grounded condition. This choice also makes it more distinct from the dash, which does cancel momentum, at the cost of a fixed horizontal trap. This means that the two moves are very complementary. Path of Pain really showcases the elegance of the design of these moves. In situations where you would have to use both one after the other, the order in which you use them changes drastically the trajectory of the character. But how are we going to go about doing the move in our prototype? We're not going to create another set of functions just for the double jump. Instead, we'll code it directly into the jump functions we already have. Since we've stated that the actual physics of the double jump aren't different, we don't need to make changes to the jumping function. In fact, the only changes we need to make are in the start jump function. we're going to create a bool variable called double jump. If you want to make triple or more jumps, you could make it an integer. From the branch where we established that the player isn't touching the ground, we'll check if the player is currently in the air using the pure function we created previously. If he is, we'll check that a double jump is available. If it is, we'll set the bool to false and set the movement mode to jumping. And with this, we already have the double jump. We just need to perform a few additions to the code so that everything works out. First, when the knight hits the ground, the double jump needs to be refreshed. Second, the animation for the double jump is different from the regular jump, so we need to change the animation used. In our jumping select, we'll create a second select that checks if the double jump is available. If it isn't, that means that we're double jumping right now, and therefore the animation should be the double jump. And with that, we have a functional double jump. This move is so simple yet expressive. It's a showcase of how simply changing the situation in which a movement is used can make it feel totally different. Good job, Team Cherry. Finally, onto the last piece of the puzzle, wall jump and wall slide. This is probably the most powerful movement ability of the knight because of its property to refresh other movement options. This power-up is, in contrast to the dash, a much more expressive ability. It allows to circumvent a lot of vertical obstacles and is extremely expressive. The wall jump works very similarly to the jumping itself, except it gives the player a bit of momentum in the direction the wall is facing. Since it also refreshes other power-ups such as the dash, it allows for some crazy mobility without ever touching the ground, giving birth to the floor is lava challenges. To analyze this power-up, we have to split it into two parts, the wall slide and the wall jump. The wall slide, for example, is a movement mode that slows down the fall of the knight, which allows for more precision in certain platforming sections. If we take a look at what happens in Hollow Knight, we see that the player has to move the knight into the wall while falling for the wall slide to activate. It doesn't proc simply by being near it. It also doesn't work while the knight has positive vertical velocity or is performing a dash. In both cases, he has to finish the movement before the wall slide procs. This is done as to not stop the knight's jump or movement in its tracks. Otherwise, it would lead to frustrating movement when trying to reach high platforms. The wall jump, in contrast, is much more lenient. If the knight is close enough to a wall, even if he isn't in the wall slide animation, he can trigger a wall jump. This makes the wall jump extremely responsive, as it is usable as soon as the character so much as grazed the wall. It's easy to notice when you try to double jump when too close to a wall. It will trigger a wall jump instead. This also means that you can interrupt a dash with a wall jump, one of the only ways to do so in game. Because of that, reproducing this will be a bit more challenging. But let's start by creating a new movement mode for the wall slide. In the change movement function, we'll make sure that you can only switch to wall slide during the falling movement mode. The reasoning for that is that you don't wall slide when grounded, neither when having positive vertical velocity, and therefore eliminate jumping and rising, as well as not during a dash. This leaves us with only falling. In the resolve movement, we'll cap the horizontal speed to the regular speed and the downward vertical speed to the wall fall speed float variable. The value of this variable should be about a third of the usual fall speed. In gravity, we can set the acceleration to the base one. But, just to make sure that the player sticks to the wall, we'll add some y component to the direction vector. For this, we'll create a float called wall direction, which will add to the horizontal component of the vector. This float will be set when we take care of the wall jump. There is, however, another property that the wall slide has. It's that it stops momentum for a few frames. We have evaluated it to be about 1/10 of a second. To reproduce that, we'll create a bool called wall landed. When we change to wall slide, we'll set that boolean to true and set a timer of 0.1 second for a function that sets it back to false. Of course, if at any point we exit wall slide, we'll also set this variable to false. With this, we can return to the resolve movement function and create a select in the downward velocity wall slide so that when wall landed is true, the max velocity is 0 instead of being our float. This creates a little stop moment before initiating the wall slide. Let's move on to the wall jump. The first thing we'll want to do is to create the condition that allows the player to perform that action. This means being right next to a wall. We'll call that condition touching wall. It will be set by a function checkWallCollision. This function will perform 2 sphere traces on each side of the knight that will look for vertical surfaces. We'll confirm their verticality by using our good friend the dot product. If either of the sphere trace detects a wall, we'll set touching wall to true. Otherwise, it will be set to false at the end of the function. This function is called everyFrame. There are a few other things we want to do when we confirm the knight is touching a wall. First, we'll use the wall direction, which will tell us the direction of the wall that is being touched. This will be useful for the wall jump. Next thing we'll do is go in the grounded function and turn the refreshing of the dash and the double jump into its own function. We'll call this one if the player is touching a wall as well. Onto the actual wall jump. This one has a lot of moving parts. Let's start with the start of the jump. If the character isn't grounded, we'll check if he's touching a wall. As we stated before, this has priority over the double jump. Therefore, this condition will be placed first. If the player meets the condition for the wall jump, we'll first set the movement mode to jumping. But since the wall jump behaves differently from the other 2 jumps, we need to do other things too. The first few frames of the wall jump moves the knight away from the wall. To create this effect, we'll set a boolean wall jump initial, which we'll set to true when the wall jump begins. We'll also make sure that the knight looks away from the wall by using the look function and using the wall direction float as a base. Finally, this jump resets velocity. Therefore, we need to set it to 0, 0, 0 before continuing. That's done for the start jump part. Let's move on to the jumping function. For the add velocity aspect of the wall jump, we'll create a select that checks the wall jump initial bool. If it is true, we'll add the inverse of the wall direction to the upward unit vector of the direction. This will make the knight jump away from the wall without compromising the upward velocity. We'll also add a bit of code to stop the knight from jumping away from the wall after half of the jump duration has expired. This bit of code will set the wall jump initial to false. We also need to set this variable to false in the stop jump function, in case the jump is interrupted early. The final touch we need is to prevent inputting horizontal movement during the initial wall jump. For this, a simple condition will do the trick in the input section. Now, there are a few things we need to fix in regards to the dash and the wall interaction. In Hollow Knight, if you dash while sliding down a wall, you will dash away from the wall. For this, we'll go back in the start dash function. Before initiating a dash, we'll check if the player is wall sliding. If that is the case, we'll set the dash direction using the wall direction variable instead. The final thing is that, during the initial part of the wall jump, it currently isn't possible to perform a dash towards the wall. That is because during the first half, we force the knight to look away from the wall. There is a clever workaround given how we coded the character. We can simply set the look direction variable based on the direction input. This variable is only used for things such as attacking and dashing, and therefore doesn't affect the rest of the movement. With this fix, we can now dash in the direction that we inputted. All that's left is to add the animations. The wall slide is pretty self-explanatory, just add it in the list. For the wall jump, we'll add another select on top of the jump select with the bool wall jump initial as the condition. When true, we'll use the wall jump flipbook, and when false, the regular jump. And with all of this, the power-ups are now completed. We'll make a small level with platforming challenges to showcase how they're used. Now, if you feel like there's something off, especially when dashing and wall jumping, you're not wrong. A key element that makes movement in Hollow Knight feel like it has weight to it is the way the camera is coded. In fact, Hollow Knight's camera has a lot of layers of complexity, so in the next episode of Hollow Knight, we'll focus on that. Thanks a lot for joining us for this episode of the Game Dev Pantry. As always, you can grab the project from the GitHub in the description. If you like the video and want more content like this, consider dropping a like or subscribing. If you want to support us further, please consider checking out our Patreon. Have a good one, and see you next month.